Yeah, so we are going to do last exercise we were doing how to make similar triangles. So this is the second exercise of constructions for class 10, 11.2, that is construction of tangents. Okay, so dimensions will be given to you, and according to the question, we'll be learning how to construct these tangents. So this is our topic for the day, construction of tangents. So let's start with the first question. The first question says, draw a circle of radius 6, and from a point 10 centimeter away, okay, let's assume that there is a point P which is 10 centimeter away. Draw a pair of tangents to the circle. So what we need to do is draw a circle of radius 6. That's the first step. So what is the radius of this? 6. So you will open out your compass, take a radius of 6, and you're going to take 6 centimeter and draw this. Now once you do that, this is the center of the circle. What you need to do is draw a line 10 centimeter long. So this is already 6. So that's 7, 8, 9, 10. Okay, you will take the scale and you're going to draw this 10 centimeter away and take this point as P. So once we get this P, what we need to do is we'll have to find the midpoint of OP. So how do you find the midpoint? By drawing the perpendicular bisector of OP. So how will we draw the perpendicular bisector of OP? You are going to take a radius of more than half. So this is 10 centimeter, right? The length of OP is 10 centimeter. So more than half, that means more than 5. You will take any radius more than 5, 5.5 ho sakta hai, 6 ho sakta hai, whatever it is. You can take anything more than 5. From P and O, you will draw these arcs. So from P, I'll cut here. From O, I'm going to cut here. फिर वही आपको करना है, P से यहाँ cut करेंगे, O से भी यहाँ cut करेंगे. So what happens is that you're going to get two intersecting arcs, one above OP and one below OP. But remember, the radius has to be more than 5 or more than half of the length of OP. If you are having smaller than half, then what happens? The two arcs will not intersect. So once we get the intersection points, what we need to do is join them. So we are going to join this with dotted lines because these are construction lines. Okay, we are going to join this. Once we get join this, you will get the midpoint here. So let us assume the midpoint of this is M. Okay, M is the midpoint. So once you get the midpoint, keep the compass at the midpoint M and taking radius MO or MP. Okay, you can measure this, keep the compass at M, extend it to P such that your pencil touches here, and then what are you going to do? You are going to draw a circle passing through P and O. Remember, your compass is at M, radius you are taking MO or MP, and then you are drawing this circle. Now once you get the circle that is also dotted because it's constructed circle, we will name the intersection point as A and B, and then with the help of a scale you're going to join P to A, okay, and you're going to join P to B. So I can say PA and PB are the required tangents, and then I'm going to measure the length of PA and PB. I will measure the length of PA and PB, and we know the theorem that length of tangents from the same external point to a circle are equal. So when you measure PA and PB, that should come out to be 8. Okay, it should come out to be 8. Very simple, because radius is 6, this is 90, we can use Pythagoras. So this is a 10. So these are actually Pythagorean triplets. The hypotenuse is 10, this will be 6, so this has to be 8. So if you have done this construction correctly, then you will measure PA and PB and they have to come equal to 8. Okay, so hope that first construction is clear. Then we go to the second construction. The second construction is you have to draw two concentric circles of radius 4 and 6. What are concentric circles? Circles with the same center but different radius are called concentric circles, right? So what we need to do is draw a circle of radius 4. Okay, let's assume this is the center, and then another circle with the same center with radius of 6. Okay, so these are the two circles. The center of the circle is open. Now what we need to do is draw tangents from the circle which is 6 centimeter. Okay, so you'll have to select any point construct a tangent to a circle of radius O from any point on the concentric circle of radius 6. So what we need to do is select any point. Let's assume this is P. And taking this point P, we need to draw tangents to the smaller circle. So first step is to select anywhere on the circle. And then I'm going to join O to P. I'm going to join O to P. And once I join O to P, I'm going to draw the perpendicular bisector of OP. So process I explained last time also in the previous question. From O and P, taking radius more than half, you are going to draw the perpendicular bisector. So from P and O, you're cutting this. From P and O, you're cutting this. And then you're going to join this. Okay, you're going to join this. And when you join this, you are going to get the midpoint of this as M. You're going to get the midpoint M. Now, once you get the midpoint of this line OP, then keep the compass at P, keep the compass at M, and taking a radius of MP or MO. MP and MO are equal because it's a midpoint. So keep the compass at M. Open out your compass till P, and then you're going to draw this dotted circle. Now this dotted circle will pass through O and P, and you will get two intersection points. One will be A here, and the second intersection point here will be B. And what are we going to do? We are going to join PA and PB. They will be the required tangents. So PA and PB will be the required tangents. Okay, we can also extend this. Okay, but the length is measured from P to A, that is the point of contact here, and P to B. Okay, so point of contact is here and here. So you can measure PA and PB, they will come equal. Okay, so procedure is clear. First, we are drawing a circle of radius 4, then another circle of radius 6. Then we are taking any point P on the outside circle. We are joining O to P. We are constructing the perpendicular bisector of OP to get the midpoint M. Keep the compass at M. Taking radius MP or MO, you will draw this dotted circle. You will get the intersection points as A and B. Then you're going to join PA and PB. They will be the required tangents, right? So we move on further to the next question. Question number 3. Question number 3 says, draw a circle of radius 3, okay, and take 2 points P and Q on the extended diameter such that they are at a distance of 7 centimeters. So we have to extend the diameter on 2 sides, and the total distance is given 7 centimeters on either side. Okay, circle is 3, and then on its extended diameter at a distance of 7, we get points P and Q. And from P and Q, you'll have to draw the tangent. So the center of the circle is taken as O, and from here you are taking a radius 3 and drawing this. So this is 3. Now with the help of a scale, what you need to do is extend it 7 centimeter on the left and 7 centimeter on the right. Okay, so what are we doing? We are extending this point O 7 centimeter to the left, 7 centimeter to the right. So OP and OQ are equal to 7. And now I need to construct tangents from the left side as well as the right side. So procedure is same. I'm going to draw the perpendicular bisector of OP. Okay, I'm going to get the midpoint of OP as M. Keep the compass at M, and you are going to draw a circle which will pass through P and O. Right, so M is the midpoint, keep the compass at M, and taking radius MO or MP, draw the circle. You are going to get the intersection points A and B. Then you are going to join PA and PB. Right, so PA and PB are the required tangents from the left side. Now what you need to do is repeat the procedure. Construct the perpendicular bisector of OQ. You will get the midpoint of OQ as N. Keeping the compass at N and radius MO, you will draw a circle passing through O and Q. The intersection points you will take as C and D. And just like what you did on the left side, the same procedure I am going to do on the right side. So I'm going to draw tangents QC and QT. So we'll get two pair of tangents from the left side and two pair of tangents on the right side. So this is construction of tangents from either side. So procedure is same. If you notice, only the dimensions are changing and they are adding on one more circle or some other dimensions are changed. Okay, we go on to the next question number 4. Draw a pair of tangents. Construct a pair of tangents of radius circle 5 centimeter and which is inclined to each other at 60. Now this is an important question. See here, what they are meaning is that this angle should be 60. The tangents are inclined at an angle of 60 degrees with each other. So this angle has to be 60. So this needs a little bit of planning because you know this angle is 90, this angle is 90. We can't change. Angle between radius and tangent is always fixed. So angle between radius, this is 90, 90, 180, 180 plus 60 is 240. So the angle at the center we need to calculate. Angle O will be 360 minus 240, 120. So this part is not given in the question, but we need to plan this out. So once we plan this out, then we can start drawing this. First, we are going to draw a circle of radius 5. Center of the circle is O. And then as per the question, the tangents are inclined at 60. So this point we don't know. So what we need to do is take any random point here, A. Just like here, we can say this is A, this is B, and this is P. So here we are taking A. We will join A to A. O. Once we join AO, that is the radius, we know that this angle that we have calculated is 120 degrees. Okay, this was not given in the question, but we have calculated here. So 120 is the angle that is at O. So what we need to do is that you draw an arc, and you know how to draw 120, I suppose. You will cut 60 twice. So without changing the radius, first you are drawing the arc without changing the radius. From here, you will cut one arc, that is 60. Again, you will cut, that is 120. When you join this, you will get the point B. Then this angle A and B are fixed, 90. Angle between radius and tangent is 90. So I'm going to construct 90 here. So I'm going to first do 60, 120. Then from here, I'll cut. So that becomes your 90 degrees. Same procedure here. I'm going to draw an arc without changing the radius. I'm going to cut from 60 and 120. I'll get 90. So now I need to join this point. And from here also, I'm going to join this point. And wherever the two intersect, that is going to give me my point P, which is the external point P. And automatically, when you measure this, this will come 60 degrees. This will automatically come 60 because here we have drawn 90, here we have drawn 90, here we have drawn 120. So this is a quadrilateral, and in a quadrilateral, the sum of angles will always add up to 360. So this is an important question because here we had to do this calculation of finding out this angle P as 120 because this was not given in the question. So we had to do some calculation. We have to make a rough diagram. So in the exam, instead of 60, some other angle comes, then also this calculation has to be done, and you'll have to find out what will be the angle P because the distance of P from the center is unknown. Moving on to question number 5. Now, question number 5 says, draw a line segment AB of length 8. Okay, the length of AB is given 8 centimeter. Taking A as the center, draw a circle of radius 4. Okay, so we are having two circles. One is radius 4, and taking radius as 3, we are taking the center as B and drawing another circle of radius 3 and construct tangents. So what is the question? First step is to draw a line which is 8 centimeter long. So this is 8 centimeter long. Now with A as the center, okay, this is A and this is B. So as per the question, with A as the center, draw a circle with radius 4. So I am going to take a radius 4, okay, and I am going to draw a circle. And remember, the center of this circle is A. Okay, this is dotted circle because this is a constructed circle. So I am going to draw a circle of radius 4. Then with B as the center, I am going to draw a circle of radius 3. So the radius of this circle is 1 centimeter less than the previous. So this circle is having radius 3. So what was this? This is 4 centimeter and this is 3. And there will be some gap left here because the total length of this is how much? 8. So 1 centimeter gap will be left. Okay, so remember this. This is 4 and this is 3. Now we have to draw tangents from A and B to the other circles. So again, from A and B. So I've got A here, I've got B here. So draw the perpendicular bisector of AB. When I draw the perpendicular bisector of AB, I'll get the midpoint of AB. Obviously, the midpoint will be here only because this is already 4. So 8 midpoint is 4. Once you get the midpoint, now I'm going to draw a circle passing through A and B. So M we have got as the center, and from M you will draw this circle passing through A and B. Passing through A and B. Okay, so this circle is from M, taking radius MA or MB, you are drawing the circle passing through A and B. So you will get intersection points here. These intersection points you can name as P, Q, R, and S. These are the intersection points. And once you get the intersection points, so from A you will join A to R, that's your one tangent. Then you will join A to S, that's your second tangent. Then you will join B to B, that's your third tangent, that is the first tangent from the other side. And then you will join B to Q. So we'll have 4 tangents, AR, AS from the left side and BP and BQ from the other side. So we'll get 2 pairs of tangents. One here is one pair and this is another pair. So this is how we do this question number 5. Then we go on to the next one, that is question number 6. Okay, you can mark this also important. Question number 6. That is ABC is a right triangle. AB is given 6 centimeter. BC is given 8 centimeter. Angle B is given 90. So first we need to construct this triangle as per the dimension. Then they are saying we have to draw BD perpendicular on AC. And then we have to draw a circle through BCD. We have to draw a circle passing through BCD. And then you have to draw tangents from the point A. So there are many parts of the question. The first part is to draw this right angle triangle, AB6, BC8 and angle B90. Then you have to draw PD perpendicular to AC. Then you have to draw a circle passing through BCD and then tangents from A. So let's start by drawing the triangle. So start by drawing the base of this triangle as 8. Okay, so this is 8 centimeter. BC 8 centimeter. And angle B is given 90 degrees. So to construct 90, I'm going to take any arc, cut 60, 120, bisect 60 and 120. I'm going to get 90 degrees. So this is my 90 degrees. After getting 90, the next step is that AB value is 6. So from here, I'm going to take 6 centimeter and cut. So this is 6 centimeter. This is 8 centimeter. And now I'm going to join A to C. So this becomes my first part, construction of a right triangle. So this we have done. Now comes an important part, that how do we draw BD perpendicular to AC. So to draw BD perpendicular to AC, I'm going to keep the compass here and select a suitable radius such that it cuts AC at 2 points. So if you take a small radius, then what will happen? It will not cut AC at all. If you take a big radius, then also it will not cut AC. So select a suitable radius. ठीक है, compass ऐसा खोलो कि AC पे 2 intersection points आए. बहुत छोटा radius लेंगे तो नहीं कटेगा, बहुत बड़ा radius लेंगे तब भी AC पे कोई intersection point नहीं आएगा. So the trick is to take a suitable radius. So B पे आपने compass रखा, and then you are drawing this arc such that it cuts AC at 2 points. Okay, this is an important part. Now from this point and this point, okay, you are going to cut here arcs. यहाँ से भी काटना है और यहाँ से भी कट करना है. These are the 2 points and you can cut here. So from B, again I'm repeating, you select a suitable radius such that it cuts AC at 2 points. You will get 2 intersection points. From these 2 intersection points, you're going to cut this arc. Now once you do that, you can join B to that point. And when you do that, you will realize that this point BD will be perpendicular to AC. So this is how we draw BD perpendicular to AC. Now we have to draw a circle passing through BC and D. We have to draw a circle passing through BC and D. So we know that angle in a semicircle is a right angle. So this is 90 degrees, right? So if this is 90 degrees, angle in a semicircle is a right angle. That means this is a diameter. Because semicircle kya hota hai? Semicircle is half circle. And half circle is only possible if this is the diameter. Only a diameter divides a circle into two parts. So that is a semicircle. So if this has to be a circle, then this has to be the diameter. And how do you find the center of a circle? Center of the circle is the midpoint of the diameter. So this total is 8. So what you can do is cut 4 centimeter from B or 4 centimeter from C. You will get the midpoint O. Now keep the compass at O and taking radius OB or OC or OD, you will draw the circle. So compass O pe rakhna hai, radius OB, okay, take the radius as OP and you are going to draw a circle passing through the points B, C and D. Okay, I'm going to draw the circle will pass through BCD. Compass is at O, radius is OB or OC or OD, and then keeping the compass at O, you are drawing this circle. Now you will get the circle. Now comes the last part. So we have drawn this triangle, we have drawn BD perpendicular to AC, we have drawn the circle BCD, circle through BCD. Now comes the last part, draw tangents from A. So if you realize AB is already a tangent, it's touching the circle at one point. And what is the length of this tangent? The length of this tangent is given 6. And now question is draw tangents. That means pair of tangents. So if this is 6, the other tangent also has to be 6. So what you need to do is from A, cut 6 centimeter on this side also. And once you do that, you just need to join this. So this becomes our second tangent. So if this is 6, this tangent will also be 6. You can name it something like D. So I can say AB is equal to AD is equal to 6 centimeters. So this is answer number 6 for you. Okay. So we have drawn the triangle, we have drawn BD perpendicular to AC, we have drawn the circumcircle or the circle passing through BCD, and we have also drawn tangents from A. So all the portions are complete. Then we come to question number 7. That's the last question. Question number 7. That is how to draw tangents to a circle without using the center or if the center is not given. Okay. Tangents when center of circle is unknown or not given. We don't know. So far we were making use of the center of the circle. So now the question is draw a circle with a bangle. Now what is the meaning of draw circle with bangle? Means you're not using compass, you're drawing a circle with any circular object. In this case it's bangle. So you don't know what is the center of the circle. And then the question is construct a pair of tangents from this point, from a point outside the circle to this circle. So the first thing is to find the center, because I need to find out how to join O to P, but I don't know the center because I have not drawn this with the compass, I have drawn with a bangle. So how to find out the center? You have done this process in class 9. So you can take any 3 points on the circle. Step number 1, take any 3 points on the circle, join A to B and B to C. Okay. Step number 1 is take 3 points on the circle, any 3 points, anywhere. And then you will join the 3 points A to B and B to C. Then construct the perpendicular bisector of AB. So from A and B, taking radius more than half, I am cutting these arcs. And repeat the process from B and C. From B and C also cut arcs. So you can change the radius obviously, but from B and C, it has to be radius more than half. Whatever you take from B, the same you will take from C and draw the perpendicular bisector. So I'm going to join this, and I'm also going to join these points. And what will happen is wherever they intersect, that will give me the center of the circle. So to find the center of the circle, the step is take 3 non-collinear points on the circle, and you get 2 chords, and then you can draw the perpendicular bisector of these chords to get the center of the circle. Now, once you get the center, it's simple. You can join O to P, the same procedure as we did in the earlier. Construct the perpendicular bisector of OP. Now the distance of P is not given. This can be taken anywhere. Construct the perpendicular bisector of OP. You will get the midpoint of OP as M. Once you get the midpoint, keep the compass at M. Taking radius MP or MO, you are going to draw a dotted circle because it is constructed circle. So I'm going to draw the circle. So from M taking radius MP or MO, this is happening. So I'm going to get intersection points here. So intersection points here, you can name it as per your wish. Let's say this is Q and this intersection point is R. And in the next step, what will we do? We'll have to draw the tangent. So you will join P to Q, that's your first pair of tangent. And you're going to join P to R, that's your second pair of tangent. So PQ and PR are your respective tangents. So obviously PQ and PR will be equal on measurement. So these are the required tangents. So when the center is unknown or not given, first step is to find the center of the circle. And once you find out the center of the circle, then only will you do the normal procedure, right? So this is how we do this circles. And of course, in the exam, what happens is that you are only given questions where dimensions are changed, otherwise the procedure remains same.